catenation. So catenation is nothing but the self-linking. Catenation is self-linking of atoms. Self-linking of atoms of one type. Atoms of one type. So here it is defined as the self-linking of atoms of one type. So this is very important part. Self-linking of atoms of only one type. And so property of catenation. So this property of catenation is defined as the self-linking of atoms of one type. Only one type of atoms when they are joined together, then it is called as catenation. So there are very few elements which exhibit catenation. So like carbon, silicon, germanium, tin, lead. Only these elements, carbon, silicon, germanium, tin and lead, they are group 14 elements or carbon family only. This few 5 elements they exhibit catenation, and in the 5 this carbon has maximum tendency of catenation, followed by silicon, then germanium, then tin, then lead. See, lead is a metal. Lead is a metal. In spite of that, it exhibits little catenation. Tin is metal also. Then, so see what we can say. Carbon is the most important element. Carbon is most important element of exhibiting catenation, and this carbon has maximum tendency of showing catenation. Maximum tendency of showing catenation. Maximum tendency to show the catenation. And it is due to 2 points. A small size. Carbon has very small size. Carbon atom is very small size. And high negative character. So these 2 points are maximum in case of carbon. So this is the reason. Now the effects of catenation. So due to catenation, carbon is able to form bonds in a variety of manner. So the effects. So due to this, carbon atoms can join together in variety of ways. Thus, carbon atoms can join together. Carbon atoms can join together in variety of manners to form numerous hydrocarbons. So this is also Very important point that why hydrocarbons or the organic compounds are in abundant in very large number. Abundance of organic compound is due to catenation. So just I am going to draw how it can. So organic compounds are there. Then you all must find the diamond, graphite, fullerenes. These are all allotropes of carbon. These are all allotropes of carbon. So the all have unusual properties. All have unusual properties. That diamond hardest material, graphite softest material, but it is very soft as it is used penicillin, but it is very soft. On the other hand, diamond hardest material. Fullerenes have unusual properties. Carbon non-metal, but fullerene is conducting in it. And diamond can sparkle even in dark. Both have very high melting point, very high boiling point. So they are made up of pure carbon. Actually, the carbon has maximum tendency of catenation, and so this, let's take the case of diamond. So one carbon, tetravalence is there. One carbon can attach with the 4 neighboring carbon atoms. Now this carbon, like this carbon, so all are at the tetrahedron. So in this manner, you can imagine, the complexity. Let this carbon like this. So as a result, the density of the carbon, this graphite, the hardness of the graphite is maximum due to this reason. There is complete intermingling of the carbon atoms and they are very close to each other. And as a result, this is the one example in case of diamond. Now, take the case of hydrocarbons. See, this is one form, a straight chain. Now see, this is branch chain. 4 carbon, 4 carbon. Then 4 carbon. So like this, 1, 2, 3, and 4. So just 4 carbon can have the 4 forms. Now there can be some more forms also. See how we have drawn 4. Now see how many are possible. This is 5th. Then 6th. This is 6. Then there are again different 7. Let it be 7. Just tendency of carbon. 8. So the enormous compounds of carbon. This is alkyne. This is alkyne. So just I have drawn 8, but you can have at least 50 types simply by adding other elements like oxygen, nitrogen. So this is very specific about the organic compounds or hydrocarbons that due to catenation, the varieties produced, the compounds are in very large number, and we have the infinite number of organic compounds all around us. They are very complex in nature. So complexity is produced in the nature by the tendency of catenation.